Welcome to the Explainer. Today we are quite literally unrolling a master blueprint, one that fundamentally reimagines computing by using mathematical geometry. Drafted on graph paperback on May 8, 2026 by Emily Newton and Christophe Schouprade, and deeply inspired by the work of Jean-Claude Perez, this framework does something amazing. It takes elegant number theory and transforms it into a functional biomimetic design for next-generation artificial intelligence and quantum computing. So let's unpack this blueprint together. It's called the Perez Hourglass Field Equation, or PHFE for short.
Here is our structural roadmap for today. We'll start with the paradigm of computing sand, then move into our base mathematical materials. Look at assembling the hourglass engine, explore perfect recall with FAM, and finally gaze into the quantum horizon.
All right, to begin our assembly, we first need to understand a massive shift in how we actually view mathematical structures. Section 1, the paradigm of computing sand and its phase transition.
So, the absolute crucial point here is that we are moving away from treating shapes, like Pascal's triangle for instance, as static observed objects. Instead, we are transforming them into active, continuous fields where computation is constantly happening. Historically, we've looked at fractal patterns simply as static objects with fixed initial configurations. But this biomimetic blueprint asks us to treat them as continuous, real-time evolutionary fields. Imagine looking at a photograph of a whirlpool, right? And then suddenly, you press play, and the water actually starts spinning. We are taking the mathematical equivalent of a photograph and turning it into a living, breathing engine.
And this brilliantly illustrates that evolutionary transition. We go from a static combinatorial object to a continuous dynamical field. The sand is no longer just passively falling in the hourglass. It is actively computing. It's using patterns like Fibonacci and the golden ratio as actual mathematical gears driving the machine. The grains of sand moving through this hourglass aren't just subject to gravity anymore. They are data points being processed by the very geometry of the hourglass itself. It's truly a game changer.
So here is our first real look at the overarching master blueprint. It's this beautiful, dynamic EM quantum incarnation that unifies these fractal shapes into a singular, continuous engine. You can clearly see the golden self-similarity curves mapped out, utilizing a golden ratio value of phi equaling 1.618. Notice that torsional symmetry breaker right at the neck of the hourglass? That right there is the core functionality of the PHFE. It translates those static combinatorial origins, things like Pascal's triangle modulo 2, the Fibonacci sequence, and Lichtenberg branching, into a fully functional electromagnetic coupling system.
But of course, every great machine needs raw materials. Let's move to Section 2, Base Mathematical Materials and Structural Drives.
Think of these three elements as our primary building blocks. First, the golden drive utilizes the golden angle of 137.5 degrees to inject harmonic self-similarity across all scales of the field, which gives us adaptive scaling. Next, the Fractal Laplacian. This is the stochastic trigger. It generates those lightning-like tree branching structures along high field gradients. And finally, my favorite, the Parity Projector. Think of this like an unbreakable vault door that locks the system's mathematics in perfect balance. It enforces what the blueprint calls Theorem 7, preserving parity and symmetry even when chaotic structural noise tries its hardest to break the system apart.
Drafted beautifully in classic blue ink on this cream graph paper background, we can see exactly how these three components are structured. We have the stunning nautilus-like spiral of the golden drive. Then, the fractal branching of the Laplacian, perfectly mirroring the dielectric breakdown we see in physical systems. And we also have the Parity Projector, visually represented by a locked vault within geometric diamonds, symbolizing that unbreakable symmetry protection. These three pillars combined are what make the computing sand possible.
With our materials clearly defined, it is time to assemble them. Section 3, Assembling the Hourglass Engine and its Bidirectional Design. Here we see the bidirectional folding completely in action. The top cone, which we call the North Hemisphere, simulates the spatial expansion phase with additive Fibonacci-like growth. Then, the bottom cone, the South Hemisphere, simulates the compression phase through subtractive parity filtering. And right there at the center plane, the Theorem 7 Parity Projector actively averages the field with its own mirrored image. This bidirectional folding locks these two opposing forces together, basically preventing the entire system from ever collapsing into chaos.
Now, this synthesis architecture acts as the master legend for our blueprint. It explicitly ties every dense, complex mathematical variable to a precise, functional purpose within the engine.
For example, look at the complex order parameter represented by psi. That is literally the mathematical manifestation of our computing sand in motion. And notice the recurrent memory kernel halfway down the list. That is the exact component that enables associative recall, which we are actually going to explore in just a second. Every single piece of this mathematical puzzle has a concrete functional job.
To actually build this in the digital world, the biomimetic engineering plan dictates a very strict three-step numerical modeling process. This ensures the classical mathematics translate perfectly into a stable Python simulation, because you don't just draw this, you compute it. The plan starts with a pseudospectral method on a spatial grid, often a torus shape. It then moves through temporal integration using Fourier and Runge-Kutta transforms. But the absolute most critical step is the third one, stability and control. Without strictly monitoring parity violations to enforce Theorem 7, the engine would literally break apart under its own complexity.
So, let's look at the primary, real-world classical application of all this math. Section 4. Perfect recall with PAM and associative memory. This brings us to PAM. It stands for Perez Hourglass Associative Memory, and it is an entirely new flavor of memory architecture designed specifically to be resilient to structural noise. It's essentially ready to power next-generation artificial intelligence. PAM is the specific dynamical realization of fractal associative memory within the larger PHFE framework we've been discussing. The ultimate goal here is to achieve what the blueprint confidently calls provably perfect memory architectures.
Notice the precise mechanism at play here. A deeply noisy, chaotic signal crashes into the system, passes through the recurrent memory kernel modulated by the golden ratio, and emerges completely restored as a perfect signal. This is why this matters so profoundly for AI. Because of the recurrent memory kernel, acting as a golden ratio modulated window, it actively filters out stochastic noise through Theorem 7 parity enforcement. The geometry of the hourglass physically corrects the data, outputting a clean signal. It is noise-resilient associative recall happening right before our eyes.
But as any visionary engineer will tell you, solving the classical problem is just the staging ground for the quantum leap. Section 5. The Quantum Horizon and the QPHFNA Framework.
When we compare our classical PHM architecture with the quantum PFE framework, it marks this incredible transition from physical pattern formation straight into the realm of coherent superposition. Classically, we rely on standard electromagnetic coupling and physical field dynamics to filter our noise. But to scale this up for the quantum supercomputers of tomorrow, the blueprint introduces a new nonlinear Schrödinger-like equation. We actually take those unbreakable parity protections and map them directly onto quantum probability states.
Okay, let's dive into this final marvel, the 5D modular oscillator. This is a specialized component that creates fractal interference patterns across multiple dimensions, allowing those noise-resilient protections we just saw to exist directly inside quantum probability states. Just look at the sheer geometric complexity of this structure. It's an explicit modular oscillator term labeled V-mod 5, utilized exclusively in the quantum framework. It allows the energy flow from a classical FAM vault to cross the threshold into a quantum FAM system, creating coherent superposition that scales across 5 dimensions simultaneously. It's mind-blowing.
As we roll up this graph paper blueprint, I want to leave you with this final thought. We are no longer just looking at abstract math. We are looking at the foundational architecture of our technological future. The Perez Hourglass Field Equation proves that the harmonious patterns found in nature, the golden ratio, fractal branching, and perfect symmetry, can actually be harnessed to build unbreakable memory systems and quantum engines. So what breakthroughs await when the biomimetic fractal geometry of nature fully powers the artificial intelligence and quantum supercomputers of tomorrow? Well, that is the ultimate question this blueprint asks us to solve.